All right, we can go ahead and get started. Good morning and happy Friday. Thank you guys all for joining today. We're excited to have you on and get talking with Jamie. Just so you guys know, you can use the Q&A box at the bottom to ask any specific questions to Jamie or Ron, and we will be monitoring that. But with that, I'll go ahead and pass it over to Jamie to get started.
Okay, fantastic. First of all, can you hear me, Lizzie?
Yep, hear you loud and clear.
Okay, yep. And I have my camera on. I can't see myself. I don't know if you guys can see me, but good morning, everybody. My name is Jamie Gettler with MSC Industrial Supply, and welcome to, for the next 55 or so minutes, we'll be spending our time talking about MSC MillMax, explaining why it's a valuable solution for our customers. Several of you, our customers, are on the call, and we're looking forward to introducing the solution, maybe clarifying even more deeply. You probably have heard about MillMax, maybe from our sales team or from our metalworking specialists. As Lizzie mentioned at the outset, I highly encourage you to use the Q&A. We've done probably a dozen webinars like this in varying levels of attendance. I think, in the 150 to 200 early on, and today probably closer to 20 or 25 is what we're registered. Perfect size to interact and open it up for questions. Ron Efforting has joined me, and Ron is also with MSC. Ron and I both work within our innovation department. Ron will see your questions, and he'll stop me in my tracks at the right time to offer up your question, in which hopefully I have an answer for you. Most times we do have an answer for the questions that are asked, and we'll continue forward from there. So looking forward to hearing from you is the essence of it. So let's go ahead and let's get started. And the first thing is what's the objective of the call today? We're going to talk about, obviously, MSC MillMax. We're going to explain how it works and why it works, but also, spend some time sharing real world examples of the performance improvements made to date. What's great about MillMax, now we officially announced via press release about 11 months ago, MSC MillMax, and there was a great magazine cover story article related to it that came out about that time. And 11 months later, through the pandemic and all the other things that are happening, we just continue to have great success after great success with the technology. And so when I talk about these performance enhancements that we've made to date, man, they're really building up, and there's quite a few of them. So each time we do one of these, I try to inject in, a different success or a different angle to consider for our customers, because this technology truly can be invaluable to you and transformative for your particular business. So at the outset, what I would share with you about MSC MillMax, but also about our innovation department and MSC as a whole, it's all about making our customers better. Our brand promise of built to make you better is prominent within the organization, and hopefully our customers feel the same way, and our suppliers, shareholders, and whatnot. From an innovation standpoint, we look at three main things to ensure that anything we put on the market that has to do with machining or metalworking or durable goods manufacturing includes some aspect of what you see on the screen right now. And so I'll hit on that later with some specifics, but generally speaking right now, American businesses, particularly machining and manufacturing customers, are interested in improving profitability. Again, as I said, as we do these webinars, it's interesting, the dynamics and the changing environment. In the macro economic landscape today, obviously inflation is happening out there. And in some cases, our end user customers may not be able to increase their pricing because of contractual obligations or whatnot. And so maybe profitability for you is crunched right now, or the opportunity for you to make more money on the parts that you're machining or making, manufacturing, is out there. That's typically the most important, or the number one concern, as you can see on the screen. So MillMax, goes right at that. And like I said, MSC as a whole, but certainly our innovations department, we're trying to find ways we can help our customers become more profitable. The second piece of it is, can we help you find or create capacity on your existing equipment? As much as, folks would love to buy new equipment, boy, if you can grow your revenues and do so on the existing equipment that you have through cycle time, responsible cycle time reductions, we look to try to help you in that regard. MillMax does that as well. And then overcoming the skills gap. That's all about productivity, human resource productivity. That could be programmers, that could be engineers, that could be estimators, machinists, and the like. If we can find ways to improve their ability to do more in a shorter amount of time and use technology to help them do that, then we're hitting on the marks of what American manufacturers are looking for. So you'll see some references to that as we go forward as well. MSC MillMax, is a technology that the general technology, as you'll see in a moment, of striking a tool with a small hammer, measuring how that tool vibrates in a spindle, that technology has been around for a little while. However, there were some recent advancements that were made that really made it intriguing to the machining industry as a whole. And so MSC said, hey, why can't we go ahead and take this technology, put it out there for direct access and easy accessibility to our customers through our metalworking specialist team? And we've done this in conjunction with the Department of Energy and Oak Ridge National Laboratory specifically. At Oak Ridge National Laboratory in Eastern Tennessee houses what's called the Manufacturing Demonstration Facility. And that's where the domestic experts in manufacturing reside. One of their primary focuses, and you might see this, there's some videos that we recently cut in an MSC series called Tooling Up, where I outline specifically the findings and what you see on the screen right now, which is Executive Order 13806, that talks about the need to improve manufacturing, supply chain independence, and whatnot in America. So we kind of collaborated, or not kind of, we did collaborate with U.S. manufacturing leadership and said, hey, if we take this out there, boy, we can really help America become more resilient, more safe, more supply chain independent. And that's never been more important than it is these days in most people's eyes. But at the same time, those improvements also help the profitability and productivity of our customers in their business, directly their commercial business. As I mentioned at the outset, before we get into MillMax and the specifics of it, the story about MillMax, some of the real technical aspects you'll read about, it was in the October 2020 edition of Modern Machine Shop. It's a longer article, but it's a really cool article that really documents how this technology came to be and how MSC collaborated with the DOE to make this a reality. Okay, so let's talk about the technical aspects of this and how and why it works. So, MillMax focuses on a number of different things. Probably the most, I would say, visible, but it's audible in a lot of cases first, is chatter. Chatter is bad, as we all know that are on this call. For anything regarding manufacturing or machining, chatter causes bad surface finishes. Chatter causes, in some cases, scrap. It is bad for the cutting tool, which limits tool life, which means you spend more on tools. It's bad for the spindle, depending on how much chatter is happening, what size tool is happening, all kinds of bad things. Surface finishes obviously are no good when you have chatter. So the idea was, can we identify ways to avoid chatter? It's not to fix chatter. You can't fix chatter, but you can avoid it. And MillMax does that, and it does it in a very short amount of time. A great illustration of how chatter begins is really understanding the system that is milling. And it really includes three things. If you were to take, what we'll show you here in a moment is how MillMax works, but if you were to strike a spindle, which is what we're seeing on the monitor right now, if you were to strike that, that's going to vibrate. You wouldn't be able to see it with your naked eye, obviously, but it is going to vibrate at a certain frequency. There is no immovable structure out there. You put a tool holder in there, in that spindle, and that's going to vibrate at a different frequency than the spindle is of that machine, or the machining center itself, and anything that's around the machine, frankly, the floor it's on, and so on. Now you add a cutting tool that has a number of different flutes, that has varying lengths of stick out, all these different things. And that system only wants to operate in most cases at a couple different stable areas. What MillMax identifies, and again, we'll show you here exactly how that works in a moment. What MillMax identifies is what are the stable speeds and at what feeds can I operate this end mill in this holder, in this machine for the material I'm about to cut in a most optimal manner, in a stable manner and in an optimal manner. We'll show you exactly how that happens. But this is where chatter begins. It's the varying frequencies across this system that make identifying speeds and feeds challenging. We can see chatter, right? And so if I go ahead and click this video, on the upper one, you're going to see that this end mill, and you have a red dotted line going down there, and this super slow-mo is showing you how left and right, you'll see the vibration that's happening, and also notice the varying chip sizes that are coming off of this tool. Whereas at the bottom, after being tapped and MillMax identified a more stable operating speed, you can see the difference in the way that tool operates. And you can only imagine, of course, that surface finish is going to be much better. That tool is going to last a lot longer. Just overall productivity is optimized for sure. So you can see chatter. The impact of chatter, as you can see here also with the surface finishes, as I mentioned a moment ago, we recognize that avoiding chatter is the name of the game in milling. And milling is different than all other operations of cutting tools, particularly because there's multiple flutes. Some of them are in the cut and some of them are not. That makes it different than turning, makes it different than drilling, makes it different than all kinds of different machining operations out there. And of course you get chatter and turning from time to time because of this, because of the lengths of holders and whatnot. But milling predominantly, you think about chatter more frequently. The idea is, what are those stable speeds? So I'm going to move to what is a video that is on our website. It's better to operate it from there than it is directly from a PowerPoint. Historically, as we go through this video, and I'll stop strategically at a couple different points to explain a few things, we always actually always have questions subsequent to us showing this video. So, you know, get ready to use that Q&A box and shoot a question over. But in the meantime, I'm going to go ahead and start the video. It's about 2.5 minutes. Like I said, I'm going to explain a couple things along the way. And Ron or Lizzie, if you can let me know that you can hear. This is our first time using Zoom. Historically, we had used a different outlet. So let's make sure that this is working.
Yep, we can hear it.
You can hear it? That's great.
Yes,
Here we go.
We don't make milling machines, milling tools, or milling software. We just make them all mill better. Here's how. Unlike other machining operations, where the cutting edge never leaves the workpiece, milling has hundreds of individual tooth impacts per second, generating forces that cause deflection and vibrations. Like this 75-pound anvil, every tool is flexible and vibrates at its own unique frequency.
Okay, so already a really great place to start if you've not witnessed a MillMax test or MillMax demonstration at your facility or somebody else's, or other places where we've done some demos. So obviously we're in a horizontal machining setup at this point. You have an end mill sticking out pretty far, frankly, for the diameter. It's a length ratio is hanging out there pretty far. You got looks like a heat shrink, obviously, holder that's going on here. But what we do is we take this small kit that our metalworking specialists nationwide, we have 140 metalworking specialists around the country that are all trained and prepared to support our customers' business with this particular MillMax kit. But you can see this hammer. On the other side of this hammer is a cable that attaches to our laptop. And upon striking this tool 180 degrees from the other side of where you see an accelerometer, that accelerometer is going to measure as I strike that tool. That accelerometer is going to measure how much that tool vibrates in that holder and in that particular spindle, which would be different from machine to machine. It's really important to note. But we'll strike that tool strategically about 5 times to identify how much that tool is going to vibrate, to understand where that system wants to operate in conjunction with one another. It helps us identify the stable RPMs that tool wants to be run at for the material of your choosing. And we'll continue on, but this is how a MillMax test is started up. Those cables both go to our metalworking specialist laptop, which will ultimately output, what we'll show you in a moment, is a dashboard that will tell you the ideal way to operate that tool.
Why is this important? The tool point deflects and rebounds at a frequency determined by the flexibility of the tool holder and spindle. You also have the tool impact frequency determined by the number of teeth and spindle speed. You have to get the timing of these two frequencies just right. If you do, each tooth is cutting equally, so tool life, productivity, and quality are maximized. If the timing is off, a tooth arrives too early, undercutting and throwing off the next tooth. It arrives too late, exceeding the programmed chip thickness, leading to premature tool failure, poor surface finishes, and possibly scrap. This timing mismatch keeps getting worse and leads to chatter.
All right, another really good place to stop. Obviously, we just heard chatter. We saw chatter a little bit ago. We saw the slow motion camera showing you how that tool vibrates in the midst of chatter. The reason I stop here is not only we've all heard what that sounds like. You'll notice over here on the bottom left is it's a very large microphone. Frankly, we carry a smaller microphone as part of our MillMax kits, and I'll talk about this briefly later. But we also have a situation that is part of MillMax that is able to listen to existing chatter. So the scenario might be we show up at your facility and we hear, we hear a milling cutter chattering, 50 feet away. We can actually go to that machine, enter in a few bits of information into our laptops about the operation. What diameter tool is it? What kind of machine? What's the max RPMs? What material are you cutting? So on and so forth, a few bits of information, and then listen to that chatter for a predetermined amount of time, probably 30 seconds, we'll say. And then we plug that, the microphone into the laptop, which we run that sound file through our MillMax equipment. And it is able to tell us the operating speed that's closest to where you're at, or that would next achieve stable operating parameters. And that's without even stopping the machine to identify that. So a little bit different than what I showed you with the hammer. You have to stop the machine to be able to do that. With this, you have to have a chatter situation already happening. But I'm going to share more about what we call MillMax Harmonizer in a little while. But what a really cool way to be able to optimize your milling processes just by listening to the sound or the frequency of that chatter.
Without knowing the tool's frequency, the common response to chatter is to slow down the spindle speed, vastly underutilizing the capabilities of your machine and tooling. As we said earlier, every different tool.
So it was important to note there, even if I can go back just for a second, solid end mills. So, high-speed steel, cobalt, carbide, whatever, ceramic, doesn't matter what material, obviously, but also indexable or insertable, depending on the way you say it. Tools are ready to be optimized using the MillMax service. For the kits that we carry with us, where we're actually striking the tool with the hammer to identify the optimal operating parameters, 3/8 up to 6 inch in diameter is the sweet spot for the kits that we have. Underneath 3/8 makes it really difficult. We actually have a smaller kit floating around the US right now that we're becoming more acclimated to. So you think about small diameter milling that's abundant in medical parts machining and some other areas, we would use that. But it's important to note, a lot of times you'll see solid end mills being tapped in a MillMax type scenario, but indexables are just as relevant and ready for improvement.
Tool holder machine combination vibrates at its own unique frequency. The challenge is that there are billions of potential combinations. MSC MillMax measures the frequency of each tool and instantly generates.
We're going to look at a live dashboard as soon as we're done, and this is the output. This is what we use to help identify those, or to showcase those stable speeds. You can see there's multiple stable areas of RPMs that tool in this particular situation would operate in, and we'll look at a live one here in a moment.
Generates a dashboard that calculates the precise stable speed, feed rate, width, and depth of cut for maximum performance. It also determines the best speeds for surface finish and accuracy. You will always know where to run. This patented and proven technology is in use at the world's largest manufacturers. It is available exclusively from MSC's trained and equipped team of metalworking specialists. Contact your MSC representative for more information.
Okay. All right. Hopefully that helped our audience, understand MillMax, see how it works, a little bit of an explanation on the physics behind it and how we operate it. Ron, I'll ask real quickly. Are there any questions so far?
None so far, Danny.
None so far. All right. Okay. So, folks, please feel free to ask away questions that you may have. So we'll go back to the PowerPoint here. So when we talk about, the MillMax test and capturing the frequency of each particular milling cutter, holder, and spindle combination, what historically was developed was what's called a stability lobe diagram. And you can see here, this is a mechanism that allows you to understand, whereas in red is an unstable, that where you have these red, we'll say checkers, part of this graph or this diagram, is an unstable area. Any areas that are not in red, that are in white in this particular case, are stable. Any areas we'll show you in a moment on our dashboards that look like that speedometer that are in yellow, what we refer to as a warning track. So that's an area in between, okay, it's stable, it's not going to chatter, versus unstable, it's going to chatter. And in between is that warning track that says it may chatter, it may not, but it's going to be really close to chattering. But in this particular stability lobe diagram, all the different combinations of where this tool can be run in terms of an axial depth of cut in relation to the spindle speed are just gigantic amounts of difference that any human, even the best application people, we have great application specialists at MSC, our suppliers do, our customers have absolutely amazing programmers and machinists and so on. What MillMax has is information that humans just don't. We don't understand or know how that frequency relates. And so we end up with a dashboard like we do here, where that red is not a good running operating condition. The yellow is getting ready to chatter, but that green is a stable area. What we find probably in the 80 to 90% of time is that our customers are operating in a less than optimal range. So what happens for the majority of us, I used to be an applications guy, years ago, and I know that by and large it's still done this way today. The manufacturers will offer you and us a surface footage range, say between 500 and 1,000 surface feet and 316 stainless. This end mill wants to run and at a certain feed per tooth, and on the minimum side and on the maximum side, and we typically go right to the middle. So in that case, we might say, all right, 750 surface feet. If 6 thou per tooth was in the middle, we would start there, and we plug that tool in, and we program it to run at that condition, and it may chatter, it may not. What we typically find is around half the time that is a stable parameter, but half the time it's not. Depending on the machine, depending on the material you're cutting, your response to hearing that first cut and that trial and error sense might be, okay, we need to turn it down. That's historically what we have done as well, and our supplier partners have done. What we don't know, and none of us know, is that there's a stable area here. And again, we're going to look at a live dashboard in a second, but maybe around 11,000 RPMs. There's another stable area around 13,500, and there's a stable area all the way at max RPMs at 14,000. And in our trial and error ways that historically that are used, you're turning it up, you're going to run into chatter, and you're going to say, you know what, we got to back it off. Let's stay at 7,000. That's better than what we were before. But there's all this productivity that's out here, and again, MillMax is really the ideal way to identify that. So let's take a look at a live dashboard. All right, let's see. So here is a live dashboard. This is what we supply to our customers upon the completion of a MillMax demonstration or test. What I would highlight and showcase to you is that this is a fully interactive HTML5 type file that you can move this depth of cut and width of cut around to identify what is most important. We've been talking a lot about speed. We've been talking a lot about, say, material removal rates. By and large, that is the most important for most customers, but you also have surface finish that comes into play for other customers, depending on the type of operation you're running. Now, every one of the times that I move this around, you can see that RPM range is showing different stable areas for what that machine is capable of doing. And in this case, this is probably 60, 61, okay? Now, that every time I move that is essentially a test historically that any one of us would have done. Hey, let's try it at, a half-inch deep, 140 wide. And we're going to find that the speeds and feeds are way down here. Okay, let's try, taking half the cutter. What can we do? All right, we can take half, but how many times and how many minutes and how many broken tools would we need to get to find that? And that's really where the beauty of MillMax comes into play. It avoids all of that trial and error. It takes you directly to what the answers are and allows you to begin your cuts or even your programming and estimating, quoting with all the information at hand. Maybe you suspected that you would operate at 74 inches a minute, right? But in reality, with MillMax, you're looking at 147 inches a minute is also capable or possible. If the milling on that part with this particular tool was a significant percentage, say it was a big pocket on a part, a big percentage, boy, what a savings amount that you might experience by knowing that information in advance. So, Ron, any questions so far?
Actually, we have two right now, Jamie.
Okay,
and
fantastic.
they're both very similar, so I'll sum it up into one.
Yeah, go
Does
for
the
it.
system have any way to account for varying degrees of part rigidity?
Mhm.
I have found harmonic/chatter can be caused from both tool and workpiece.
Yeah, and so the other question is along the same line, Ron?
Pretty much exactly the
Okay,
same.
great. It's a fabulous question. We get it all the time. Couple things. Absolutely, you're right. And so MillMax, the way that I've shown it to you at this point, does not detect workpiece rigidity. We are able to do that using our MillMax kit if we need to. But what I would tell you is our experience is showing us about less than probably 2 to 5% of the time, chatter when it is happening is a result of substandard fixturing or work holding. So what we can do is if we see that we have, and really whoever asked the question, it's a great question. Say we have a big fat stable area like this, or even like the one that's over here. If we're still getting chatter, then it's probably the workpiece, right? But my point is, it's I don't want to say few and far between. It's pretty rare though, folks, that it is the workpiece. Now, we recognize that sometimes you're machining large items with wings on them or other, components that jut out of the vise or the fixture, and it's less than stable. We are able to tap the workpiece to identify how much vibration is happening there and somewhat overlay dashboards on one another to find where does this system of this end mill tool holder and machine tool want to operate, and then how is this part that they're about to machine vibrating, and then be able to combine them to find what is stable for both. It's a really great question, and it is something that's extremely relevant, but we have ways to help in that regard.
Got another one, Jamie.
Yeah, sure.
If we break an end mill or change end mills, do we have to tap the tool every time?
The answer is no, you do not. That's a great question. So, once you tap a tool in a tool holder in a certain machine, a couple things are key. Is the tool needs to be sticking out the same length, what we call the stick out length from the holder, different from the gauge length that you might hear referred to within the tool holder community. So we actually take a scale to the bottom side of where that end mill is sticking out, and if you can be close within, within a few thousandths of stick out length, you do not need to tap that tool again. That allows you to use these dashboards for any number of different jobs. Sometimes folks will question the valid nature of MillMax within a job shop because you're going from one part to another part, but a lot of times you're using the same tools on the same machines. That allows you that flexibility. So the answer to your question is no, you do not need to retap them. We don't suspect a retap is necessary for several years. Quite frankly, we don't even know the answer definitively to that because we just know that it's a really long time. What we do know is if that spindle crashes or something changes significantly with that machine tool, you may want us to tap that tool again just to make sure, particularly if you start running it and it's not giving you quality operating parameters or what the dashboard is telling you is different from the performance you're getting. Really great question.
We have a follow-up to that one.
Sure.
And you may have said it and I may have missed it, but what if tools are from different manufacturers? Do they need to be tapped then?
They do. Yes, they do. So you have different substrates, you have different chip gullets, you have different rake angles, you have variable pitch versus evenly spaced, variable helix. All those kind of things come into play and they will operate differently. If you take an evenly spaced end mill that's 3 flutes from, I'll name some companies, whether it's Kennametal or MA Ford or OSG or Sandvik or any of those companies, and they look exactly alike. They probably are going to act differently, but we can help you identify that. But better safe than sorry in that case, and I would tap a different manufacturer's tool for sure. Great question. Any other ones, Ron?
That's what we got right now.
Okay, so in a keeping time in mind, we also have the ability, for an accuracy meter. The more green you see here is if you had a really fine or tight tolerance work that you're doing, this surface location error is going to help you identify, everything still is vibrating. Chatter is always existent. It's a matter of how much can you minimize it because of the nature of milling. This helps you identify that. Over here is a surface condition or surface finish monitor. So the higher you are on this particular graph, the better your surface finish. So you want to find that sweet spot of where you can find a speed associated with the high part of this graph that's stable, and that is going to give you your best surface finish. Again, we recognize in roughing, the more material you can get the heck out of there more quickly is the best. And then comes to finishing. And if you can achieve potentially your final finish on the machine, MillMax is a way to be able to help you do that. And imagine all the trial and error again, folks, that you're eliminating by virtue of being able to do this through a dashboard and then take those speeds and feeds directly to your machine tool or to the programmer and finalize them. Okay, Ron, if you have any other ones, of course, break in.
One just popped up.
Okay, good.
How often is the deviation of cutting parameters related to the specific tool / holder versus machine spindle specific?
So kind of a tough question to answer, but they all work in conjunction with one another. What I can tell you is that the tool holder, so when we take a look at an application, the best way to explain it is probably with somewhat of like what a real life scenario would look like. So if you're interested in MillMax, one of the next steps is we'll have our salesperson or our metalworking specialist reach out to you and understand, is there an application you would like us to do a demonstration to see what's possible? We'll learn about your operation. And let's say that you're using a 1/2-inch end mill, with whatever flute length in titanium, and we'll understand what machine and whatnot. We're going to recommend what we think is the best tool and tool holder for that job, right? We can tap your existing situation if need be, but we're learning along the way. And what we've learned is there certain type of holders that are more conducive for milling than ones that aren't. There's certain types of end mills that are much better than other ones in terms of their ability to find multiple stable areas at high speeds. So what we have found to answer that question is just about every machine is going to have a stable area that it can be run. And it's a matter of the combination of that tool holder and tool in conjunction with that machine to find that stable area. So really, it's the whole MillMax solution is the answer to that question. And we're able to find that either through offering up what we believe would be the best solution, or tapping your existing setup if need be. Hopefully that answers your question. That's a little bit of a tough question to answer, a complex answer, I should say.
Hey, Jamie,
Yep.
yeah, we got two more. Will this apply to thread milling?
It does. Matter of fact, it does. So if you have, if you're doing a lot of thread milling, absolutely, you have chatter that's involved in thread milling. Some of the teeth are in the cut and some aren't in the cut. Absolutely is something that is able to be, MillMax is able to be relevant for that application. Yep.
And also, is the MillMax system available for purchase, or is it only accessible through MSC Metalworking Specialists?
It's only available through MSC's Metalworking Specialists through the service that we offer. We're going to get to that towards the end. As a matter of fact, you know, when I introduce it, I hate to use the word free, but I'm going to introduce, essentially, it's a very expensive system, first and foremost. And we've invested a ton of money in acquiring these kits. And what I can tell you is the way we've monetized it, or the way we make it available to our customers, essentially can be free. And I'm going to get to that in a moment, but that's a really good question. All right. So what I'm showing here right now is the choice is yours. You saw that from the live dashboards. Is you can either go with the fastest speed to shorten your cycle times. Sometimes you'll have multiple stable areas like we saw, where you can go with moderate speed and get longer tool life. MillMax, you know, a lot of times is going to help you with tool life just because it's avoiding chatter situations. But if you have multiple stable areas, slower speeds are going to allow you to have longer tool life, and maybe that's important to you. Or if you want better surface finishes, and the ability to do that without having to run trial after trial after trial of trial and error on your machines, this is the best case scenario. So it really gives you options and allows you to know, frankly, what we say, and for ourselves, it's better to know than to guess. It gives you that kind of information. We talked about the harmonizer, and what I shared with you is that we can listen using that small microphone to existing chatter on your machine. So if you have a job right now that's on a machine that's chattering, we're able to bring the MillMax kit in, use the small microphone, understand a little bit about that operation, and help you avoid the chatter if possible. In almost every case, if not every case, we are able to do that. What's also very cool is that we had and have customers that can, so the pandemic has caused, you know, limited access to some shop floors. Now, of course, you know, recently that's opened up for the last several months, but let's say it goes back to a situation, or your facility, you try to limit the amount of people that are showing up on your floor. If you have a existing chatter situation, you can actually record it using your mobile device and text or email your metalworking specialist that sound file. They can do that same input of the application details and respond back to you with what speeds and feeds, particularly speeds, that you need to adjust to eliminate that chatter. So we can do that from the comforts of our living room, or the comforts of our offices, if you will. Really cool with Harmonizer. Again, you have to have existing chatter in order for that to happen, but that's available to you as well. Somewhat of a cool technology there. So let's talk about some of the results that we're seeing. So these are in aggregate. If you've participated in our webinars before, these look similar. I just updated them yesterday, as a matter of fact. So what we're seeing on average, you'll see here, and this is over 16 months, because we were doing some pilot testing before we officially launched it last October. So average improvement of RPM utilization on machines, average across hundreds and hundreds and hundreds of tests, is 85% improvement. It's a crazy amount. Now, we recognize that the RPMs don't mean, they aren't the be all end all metric in machining. We recognize that, but sometimes your organization has bought a machine with a higher level RPM, with the torque and the horsepower, capability. And if it's a 20,000 horsepower spindle and you're running at 12,000, but MillMax showed, hey, 18,000 is possible. There's a stable area there. That's what we're talking about here. Is on average, when we leave a shop, we're almost doubling the current state of RPMs for our customers. Also important, but not the be all end all, is feed rates on average. And so when I say this, and in all of these subsequent slides, you'll see this: steel, stainless steel, cast iron, super alloys, composites, hard materials, our new machines, old machines, you know, maybe spindles that aren't the greatest and brand new spindles. Our average feed rate improvement is over 200%, meaning we're tripling the current state on average. So if we show up and you're at 10 inches a minute, on average, when we leave, you're going to be closer to 30 inches a minute, from 10 to 30 inches a minute. That's our average. Material removal rates really are, for most people, the be all end all. Again, separating the workpiece finish or the finish requirements in other cases. This is more the jaw-dropping one for me. And again, this is a tripling of existing material removal rates is the average that we find. Now, before I continue on with what's on the remainder of the screen, what that ultimately relates to for our customers is there are some occasions that we will tap your existing situation. Maybe you're using a certain brand of an end mill and a tool holder in your machine, and you want us to see, you know, what better can be done based on all the things that I've been sharing with you. Sometimes we find that our customers already optimal. And quite frankly, when we do, it's like, oh man, you know, it's kind of a downer a little bit, but it's actually pretty impressive because in most cases, there's significant amounts of trial and error over the course of at least hours, sometimes days, sometimes weeks, sometimes years to have gotten to that point. And MillMax just showed you that in less than 15 minutes. But on average, our material removal rate improvement that we're finding, including those where our customers are already optimal, is about 200% or 3 times more than what they were when we showed up. What that creates is hours of capacity and hours of reduced cycle time. So on average, we're seeing our giving back to customers 84 hours of productivity or production time that they can put on that machine. So if a current application takes 10 minutes and we cut that cycle time, you can see down here, our average cycle time reduction right now after a year and a half is 45% less. If we cut that cycle down from 10 minutes to say 6 minutes, well, you have 4 minutes now on that machine that you didn't have before. And if the sequencing of all the other operations allows you to make use of that time, boy, that's time savings, that's energy savings, that's other work that potentially you can put on that machine, which helps you grow your revenue and improves your earnings and all kinds of other things that spin off from that. So these aggregate metrics are really mind-numbing. Thinking back to my old metalworking days when I was applying tools, if I would have showed up at a customer's facility and say, hey, this new end mill that just came out onto the market is improving material removal rates by 25%, most of my customers would have been like, let's go. I want to see how this works. I can't wait to see it. We're averaging 200. And we'd love to be able to show you, what the system's capable of. Okay, there's other potential benefits that I'll quickly walk through because of time. The questions have been great. Keep them coming, by the way. We have 15 minutes. Sometimes we create so much capacity that maybe you had in mind that you needed to buy another machine to support the production that you needed to grow your business. Sometimes we're able to help you offset that need to do that because we can show you how to make more with the existing equipment you have. Less wear and tear on the machines because the milling tools, which run roughshod on spindles in some cases, we're introducing chatter-free operating parameters or stable operating parameters rather than chatter or the trial and error that happens as well. So less equipment wear and tear. Sometimes we can get the finish that you need right on the machine, and that allows maybe to eliminate some final finishing that's offhand done by your employees. If that happens, then maybe you're not using as much abrasives or hand pads. Cutting tool expense in many cases goes down. You'll see that on a subsequent slide. And then that overall optimization. On average, Cutting Tool Engineering years ago did a study on it, and we validated it for years. The average time it takes to find stability in a milling operation is 3 to 8 hours. Just to find stability, to get this tool to work and this holder and this machine. We're showing you where optimization is in less than 15 minutes. So there's a huge time savings there. We document all of our efforts, and we will give them to you and what it means to a short run job or a long run job. It's arguable, is MillMax, more qualified for production shops or for job shops? It's equally influential in a positive way, but we will document the savings or the profit improvement that you'll incur because of the MillMax improvements. Here's some examples. Some of them have been around for a little while. Some of them are new on this slide, but you can see some of the real life across the ISO material groups, color coded for that reason: blue steel, yellow stainless, red cast iron. I added the gray one in there this time for composite, non-ferrous up in the corner in green, and super alloys in brown. We have hundreds of these. These are just a select few that I brought in. And you can see that we have cycle time reductions that are pretty significant. We have profit improvement numbers that customers have gained. Interesting, you might think on this middle one, I always love to point out this middle one here with this engine block. This is obviously an engine block manufacturer here in the States, and CGI, or compacted graphite iron. And those machines are typically run off and turnkey and exhausted of getting every second they can of cycle time out. And the customer was a little reticent about us, coming in, because they were certain they were moving, they were going as fast as they possibly can. And like I said, the technology knows things that humans don't. And we said, well, let's give it a shot. We gave it a shot and found a 64% improvement in MRR, and did such in less than 15 minutes. Now, that's far less than the 200. But the point is, here's a situation where this thing was run off, but it was so many different tools to find. This was the best operating parameter, and this is where we ended up with it. It was a pretty cool experience. Go ahead, Ron.
Is this application applicable to turning as well?
So the answer is we can. It's rare. The kit is dedicated to milling. However, if you have a boring bar that's sticking out quite a long ways, or you have a long cylinder that you're turning and you believe there's some vibration that's happening there, it's an advanced use case of MillMax. Not all of our folks are trained to that extent at this point. Our support mechanisms are able to help us in that regard. So we will give it a shot. It's not to say we'll be successful. We probably will be able to show you something, but this is really dedicated for milling, with a couple outside use cases, like I said, tapping fixtures or vices or workpieces and stability, or in the case that you're talking about, turning. So possibly is the answer. Ron, any other questions?
That's what we have so far.
Okay. All right, great. 10 minutes? Yeah, 10 minutes left. Okay, so here is an actual test that happened. I'm in Pittsburgh. And this actually happened here in Pittsburgh. I wasn't part of this one, just our metalworking specialist here had done this. As in 4140, it ended up being about a $60,000 profit improvement for the customer. You can see the before and after metrics here. This is what the customer is using, a 4-flute tool going, at the speeds and feeds here, $162 per end mill. Jason, who's our local specialist, recommended a 6-flute end mill at 900 surface feet, $115 each. You can see the MRR improvement. The feed rate improvement was extraordinary, 10 times faster. Customer was getting a half a part per end mill. Now they get 2 parts per end mill, but that annual cycle time cost was $52,499. And now, after MillMax and a recommendation from our specialist, that cycle for milling only now costs that customer $7,500. Okay, so their ability to make that much more profit was really exacerbated in a positive way by this. So there was $45,000 of savings on cycle time. So 52,000 minus 7,000 or so, right? We also showed an end mill savings because of the tool life of $13,000. So $13,000 less expense in buying cutting tools necessary. The tool change savings, because time is money and you have a burden rate that's associated with, per hour You're going to be changing tools less, and that came about $60,000. But we document this, but we don't claim this for you, but it's something for our customers to consider, and that is that annual hours saved. So because we went so much faster and tool life was so much better, we were able to save this customer 450 hours. Now, the size of this customer, I'm not sure, but let's just say it was a $5 million machine shop. And that's, I think, the average size machine shop, smaller machine shops that are out there. If they were using this, filling capacity with 450 hours at their revenue per hour rate would give them an opportunity to refill those hours with $1.1 million worth of new business if they took advantage of all of it. What if they took advantage of half of it, 550,000? But that gives them an ability to have an additional set of earnings of $110,000. That's if they're making ultimately 10% gross margin. So in addition to the savings on the existing part that we're working on, those capacity hours are now in the hands of you, our customers, or the shop owner, or the decision makers, the executives at our customers, to say, okay, so now we have all of this time on this machine. Can we add new work? Can we train unskilled workers, maybe, and try to help close the skills gap and do that? You have this at your hands. You also have the opportunity to reduce scrap. If you're milling and versus the trial and error stuff, you're not breaking end mills, you're potentially not scrapping work pieces. There's a lot of time savings there as well. So, when we share this, there's other things for our customers to think about. Let's see, we should have just a couple other slides, guys. So the way I talked about the monetization factor, I said that I would come back to it. We do not charge a service fee. We considered it and talked to our customers about it. And the idea was, should we charge you X amount of dollars to show up, almost like an HVAC repair person? It's going to cost X for us to be there. And then once we get there and we diagnose what's going on, it's going to cost X to do the work. And then we'll document the savings. And customers were like, yeah, maybe. But it wasn't resounding yes. It's not normal in metalworking is the service fee aspect. Then we said, well, what about a percentage of savings? If you believe that the savings we're documenting are real to you, and our customers almost exclusively do, what if we charge a percentage of the savings? And said, all right, we'll 10% of the documented savings. So if we save you $10,000, you cut us a check for $1,000, you keep the other $9,000 for you, and everybody's happy. Well, what if it was a $200,000 cost savings? We just documented one last week that I think was $275,000. Is a customer really going to pay us $27,500 for a 10-minute test or a 15-minute test? Probably not, right? I don't know if I would either. That's tough. And then we said, we're overthinking this. Why not do this in return for wanting to earn our customers' business? It's kind of business 101. It's kind of sales ethics and business ethics 101, which is, if I do something that's better than my competitors can do, and I improve you to that extent, shouldn't that position me to earn your business? And that's all we ask. So on the next slide, what I outline is the financial benefit to our customers is to say, let's say that we ask for $50,000 in sales for us to do MillMax at your facility. That's business that you already spend somewhere else. So if that price that you're paying for that item, let's say it was end mills and holders, is transitioned to MSC and our price is the same as you're paying, then net you're even. It didn't cost you anything. But you're getting MillMax in a position to save you all that money. And the MillMax engagements that we do, we don't consider it a successful consultation unless we're saving you money. So you really have nothing to lose here. It's just business 101. If I do a good job for you, you probably would want to do business with me. Your customers would say the same thing about your business, I'm sure. Right now, our average profit improvement, it's actually in excess of $8,000 savings per. So if it was 5 consultations, then you're getting $40,000. You're $40,000 better off than you were before because you're not really paying for MillMax at that point. We just want to earn your business. We've invested the time, the technology, the training to be able to do this, and that has come out to be really fair with our customers. All right. So common questions. We have 4 minutes left. So here's some common. Go ahead, Ron, you got something?
Will this work on drilling?
No. Now, the answer is no right now. In working closely with the folks at Oak Ridge and the leadership there, there's a possibility that they may have had a breakthrough, no pun intended, a breakthrough that is going to require further and further testing. But they're giving it a shot to try to figure that one out. And I have reason to believe that maybe they're not too far off from that. So with what we do today, no, but it may be something soon, and you'll be hearing about it from us. Good question. So first question there, does MillMax work on other things other than milling products? And so we just said no on drilling, but we did say, hey, work pieces sometimes in an advanced application or sometimes in a turning environment we can. What about live tooling in a lathe? Very popular. It's the fastest growing type of equipment these days in machining is the ability to do milling and turning work in the same machine. So you have these milling spindles in a lathe, and yes, if it's milling, it can be tapped and it can be optimized. Does it work in composite materials? Absolutely. It works in any material. Solid and indexable, we talked about. We talked about the part, and does MillMax take work holding into account? Have any tools or tool holders emerged as better than others? Yeah, matter of fact, they have. And so, you know, if you have a shrink fit machine, we're going to recommend, you know, going that route. And if you don't have one and have the ability to buy one, or maybe we save you a lot of money and that maybe positions you to be able to have the capital to go out and buy one. We're seeing that shrink fit, you know, is in most cases, not every case, in most cases, the better mousetrap in that regard. We find that in some end mills, in certain geometries of end mills for certain materials as well, that seem to work better. And our specialists have that knowledge and can deliver that along with the dashboards. We already talked about how often to tap a tool, and is it better suited for production shops rather than job shops? It's equally capable and impactful for those types of businesses. Obviously, within a production shop, if you can shave a couple seconds off a milling cycle, that could mean hundreds of thousands or millions of dollars of improved profit. But imagine being a job shop that you have, and most job shops aren't onesie, twosie. Typically, it's 50 of this, 150 of that, 25, 500. If indeed that's the case, the ability to know when you're quoting or programming what might be the case if you have an existing dashboard, and to not have to spend the 3 to 8 hours on average to find the ideal operating parameters or stable operating parameters for the end mill, and you can just start cutting right away, should save you or make you even more money. Any final questions, folks? This was really a great session.
Jamie, we've got one. How does this change OD to ID?
I'm not sure that I understand the question. Go ahead, Ron. What are you going to say?
Yeah, I'm not sure either.
Okay. So what I would say is GOETTLEJ. So at mscdirect.com is my email address. Feel free to reach out, or maybe put your name in the Q&A if you don't mind. I'll reach out in your number. I will reach out to you directly and get to the bottom of it. I'm going to try to keep it to it's noon right now. We'll answer that question for you. We'll do that offline. But Ron, are there any other ones at the last second here?
No.
Okay. All right. Listen, everybody, go ahead.
He did put his phone number in the chat for you so you could follow up.
Fantastic. I have a meeting at 12 as soon as I'm Eastern time. As soon as I'm finished, I will call you and we'll talk about the ID/OD question that you have. I hope you found this intriguing. We are seeing the results that I outlined every day. It's pretty amazing and eye-opening and jaw-dropping. We had a meeting this morning with our leaders at the DOE and at Oak Ridge, just talking about the results that we're seeing. Would love to be able to do it for you. We will follow up with you to see what your thoughts were on this and set up a demonstration if we haven't already done so, and prove it on your shop floor, and then put the ball in your court to say, yeah, man, we want to do more of this kind of stuff. So thank you very much. I hope you have a great weekend, and thanks for your interest in MSC and MillMax. Bye now.